Perpendicular lines. So we have a couple of theorems to kind of get out of the way here that will help us as we go through solving problems about this thing. First off, if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. So if I have line M and line N, and they intersect such that angle 1 is congruent to angle 2, then line M is perpendicular to line N. Because again, the only way, remember, a linear pair, the angles add up to 180. And if I have two angles that add up to 180, and they're both congruent, then that means that they both have to be 90 degrees. So they're both right angles, which means we have perpendicular lines. So next one. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. And that's kind of just a matter of I have your alternate interior. You can also think of it as corresponding, etc., etc. Any of those would be correct. So if N is parallel to P and N is perpendicular to Q, then P is perpendicular to Q. Okay, the next theorem says that if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So this is kind of going a little bit the opposite direction. If I have R is perpendicular to T and S is perpendicular to T, then R is parallel to S. Again, this goes again like corresponding. This was that converse of our corresponding angles theorem sort of thing. And so the next one says that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So if this makes sense if you think about it. Like if you're going to be crossing, let's say you want to cross the street. You're standing over in the parking lot and you want to cross Lamar to get to the school. Okay, the shortest distance, because you do not want to take any more time on that street than you have to, is going to be going straight across the street. So you're going to go perpendicular to the street. Okay, so that's kind of what we're thinking about here. So the distance from A to B is, the distance from A to the line T is the length AB. So for example, I've got these two lines that are parallel, and I have one of them that is perpendicular to one of the parallel lines, which means that it's perpendicular to the other one. And I want to solve for X and I want to solve for Y. Well, this one right here, I've got a problem because I have X and Y in the same expression. And so this one down here, whoops, where'd you go? I lost my, there it is. This one here, I only have an X. So I'm going to solve the X first, and then I can plug it in and then solve for Y. That's kind of the plan there. So 10x is equal to 90, which means x is equal to 9. So now I'm going to take this 9, I'm going to plug it in for x on the other expression. So 8 times 9 plus 4y equals 90. Well, 8 times 9 is 72, which means that 4y is going to be 18, which means that y is going to be 4.5. So another example here, distance from a point to a line, and this is kind of how we're going to be seeing these types of problems as well as far as an inequality is concerned, because if looking at this diagram here, if I want to name the shortest segment from point R to my line FO, well, as we said earlier, the distance from a point to a line is the perpendicular. So that's going to be my shortest segment. So RG is going to be the shortest segment. And so my second question says, write and solve an inequality for X. Well, we said that this is the shortest segment, which means any other segment from R to the line has got to be longer. Alright, so that tells me that FR, this line segment here, has to be longer than this line segment here. So FR is greater than RG, which means that X plus 5 is greater than 9. Now, if you remember when you're solving inequalities, for the most part you solve them exactly like you solve equations. So I'm going to subtract 5 from both sides, and I get x is greater than 4. So as long as x is greater than 4, then this line segment is longer than the other side. So x has to be greater than 4. And so we're going to be working different problems like this, but that's if you don't remember how to solve inequalities, you might go back and I think I'll put some review problems up here that you can take a look at just to get some practice, because we are going to be working with these inequalities for a little bit. I'll see you in class.